So, hi folks. Today we are speaking with Mark Brown. He is a principal program manager in Microsoft working with Cosmos DB. So, my first question to Mark is Mark, why Cosmos DB? I know it is one of the NoSQL database,
Mm.
and there are so many other NoSQL databases out there like MongoDB, DynamoDB. So, what differentiate Cosmos DB from all other NoSQL, and why I should choose Cosmos DB over any other NoSQL database?
Sure. So I can answer that. So, kind of the official definition is Cosmos DB is Microsoft's or Azure's fully managed NoSQL database as a service. So, implication there is that it's a native service offered as part of Azure. So, one reason you may want to use it is that it has high fidelity for integrating with, Azure and its kind of constituent pieces, but also other services, right? So, if I'm going to say deploy a database in the cloud, I probably want to secure that. So, Microsoft, or should say, Cosmos has very good integration into our networking services, so you can secure your endpoints within, like I say, a VNet or a subnet, right? Where you're gonna, and then co-locate those where your applications are sitting, so that you can privately talk to your database through your applications. Um, Things like Azure AD integration, so being able to authenticate, and then also even do authorization. So there's RBAC as well for our data plane and control plane in there. So you have better integration into our identity or auth and auth pieces and services there. Other things as well, like integrating with things like Azure Functions. We have really wonderful first world integration with things like Azure Functions or Azure Search. Um, Azure's Stream Analytics, Event Hubs, all those services all um, are there and easy to integrate because it's part of that whole, that Azure whole, if you will. And then other services as well. And I could go on and on about this one, but I just wanted to touch base is, you know, Cosmos is what we coined kind of an operational data store, right? So it's built and designed for OLTP workloads, right? So high volumes of transactions, that sort of thing. It's not built to do like heavy OLAP types of workloads and stuff, and that's okay because one of the other integrations we have, and one of the more recent ones, but one of the more compelling, is our integration into our Azure Synapse analytics platform. And we released this, I think, over a couple of years ago now in preview. It's GA now. The idea is that you can do a very simple kind of couple of mouse clicks in terms of integration to do a no ETL or no copy ETL into this analytical storage layer that we built, right? So Cosmos is a JSON store. So you write rows or documents as JSON, and we store them in our storage layer. This is built, this analytical storage layer is built as a kind of a Parquet file system, if you will. So we take that, and then with the magic of synapse-link, which is kind of our connection layer between these things, we will automatically copy that data over to our analytical store format, wherein then you can go and create new workspaces within Azure Synapse and notebooks, and then choose a compute layer for your queries, whether it's say Spark, so you can query all of your data in there through, say, Spark queries, or you can use SQL Serverless as well and write T-SQL queries over your data.
So when you say there's an integration with Azure Synapse, it means the data will move automatically from Cosmos DB to Azure
That's
Synapse.
correct. There's zero
Okay.
ETL. So unlike other types of integrations where you're trying to do OLAP over operational data, you do not need to write bespoke ETL routines to copy that data. It's automatically handled for you to copy that data
Okay.
from the operational data store over to an OLAP store, and the nice thing is that happens in near real time, around 30 seconds or so from the time you write new data into Cosmos, that it's available for queries over on the analytical side. The other nice thing, and I want to make this point as well, is also unlike traditional kind of solutions where you're doing OLAP over analytical data, when that data is moved from the operational store into Synapse, it doesn't have any impact on the workload for your operational data store. So this is another kind of a big drawback, if you will, is copying that data over to some other database usually takes compute and resources away from your operational data store. So while you're doing this, your applications may slow down or have other issues. That's not the case here. This is what we call HTAP, hybrid transactional analytical processing. But this is true HTAP capability that we've released within there, and it's very powerful within there, and definitely has lots of uses. Not just doing OLAP types of workloads, but also you get the whole full suite of other services that integrate with Synapse, like doing machine learning over your data. You can go build dashboards on it. You can literally do nearly anything on this. You could even use it as an archival mechanism, right? So, like, another characteristic for Cosmos is it's extremely fast because the data is stored in SSDs on cluster to where the service is running and not in a network remote store, right? Like a blob store. So you get very fast performance. However, that storage is very expensive relative to, say, blob storage. Versus in an OLAP scenario, you don't need that low latency. It doesn't make sense. So you don't, why pay for it? So you can run your queries over data that's stored there, but you can also keep your operational data at a decent size, because you can, once you write to it, you can TTL it off of there and then put that and use Synapse as kind of an archive even, but not just an archive like a blob storage. It's an archive you could query. Right. So all you got to do is just create new compute, either a new Spark or a new SQL Serverless instance, and then query for that data. So lots and lots of different scenarios for using that. But I wanted to talk about it and maybe talk too much about it because it's actually a very, very cool integration that gives you lots of stuff beyond just what OLAP.
True. Because the big thing I'm seeing here that you are saying there's no ETL, so there's no one extra process,
Yep.
and it directly the data move from Cosmos DB to Synapses. This is awesome.
Yep.
So this data is connected with the change feed of Cosmos DB.
No, not using change feed. It's a completely different internal process that we've got built internally in there.
So I am not charged for the data movement from Cosmos DB to this place.
That's correct.
Synapses.
That's correct.
Awesome.
And not only that, but let me go back to your original question. So why Cosmos? So one, it's a native, fully managed Azure service. The second reason is we're multi-model as well. And what that means is we support different database formats through the same service. So we've got we've got 5 of them now. There is our SQL API, which is a bit misnamed. It's a SQL-like syntax, but our SQL syntax is specifically designed to work with JSON data, which is not what you would use in say a Postgres or a MySQL. It's not set-based data. It's documents, right? Mm-hmm. And you need to be able to deal with things like hierarchies and other stuff. So our SQL API, if you will, is really designed for our JSON format.
But there I can use my SQL syntax, which I know and love, that select star from this table name, group by, order by, sort, and all those things.
Yeah, it allows you to leverage your SQL skills, but you're going to learn some things as you try to use that over JSON data. Are there APIs as well? As we offer a Mongo API as well. And we're working hard on that to make sure that we're supporting the later server version. So we've just released a 4.2 version, and just keep.
So when we say Mongo API, I just want to clarify for the audience. By that, we don't mean there's no Mongo inside the Cosmos DB. You are just using the Mongo protocol. So the Mongo tools and the format of their query can work over Cosmos DB. So if you have an application built over Mongo, you move it to Cosmos DB and then just change the connection string, and nothing need to be changed in application, right?
I mean, that's the idea. The reality is that in some cases there may be some tweaks here and there. There are some incompatibilities between
Sure.
the full native
But
Mongo service.
95% of things should work.
But that's correct. Like the majority, vast majority of all the stuff in there should just work for you. And yes, you can use native Mongo tools like Mongo Shell,
Mm,
Mongo Restore, Mongo Import, Studio 3T, Mongoose, whatever.
right.
It's just an endpoint with a port and a password, and you can connect and use that.
Sure.
So that's another one we've got. We also have support for Gremlin, which is
Mm,
a graph database. We have support
right.
for Cassandra, and we have multiple
Mhm.
flavors of that. We have a fully managed Cassandra API, which is our fully managed multi-tenant service. We also have a new Cassandra managed instance, which is a node-based or a VM-based Cassandra offering. That's running hosted open source Cassandra, and then customers can replicate into that using the Whisper protocol. So just basically add that as a node within their ring, and then they can seamlessly replicate in and out of Azure from their, say, on-prem. The Cassandra API is just like Mongo in that it's an emulated layer that
Right.
looks and sounds like CQL to drivers to
Hmm.
clients. The Cassandra MI is entirely different. That's a fully hosted open source Cassandra running on our managed infrastructure. So similar in that it's going to be the same Cassandra that users are running if they're managing their own Cassandra clusters. Way different
Mm,
in the fact that they do not have to deal with all of the DBA overhead that's normally associated with running your own clusters of Cassandra. So a fully managed, much easier, but more compatible way, if you will, for customers that are trying to go from running their own clusters either on prem or in VMs into an Azure cloud because they're trying to migrate their apps and their data, of course, into Azure cloud. And then the
mm,
last SDK or the last API is our table API, which is kind of a functional equivalent for the table storage service that's been around since the very beginning for Azure. And our flavor of it just provides a more performant version of that while trying to maintain that same compatibility, if you will, from that old
okay.
storage,
So
table
when we
storage.
say table, is it like key value
Yeah,
pair
that's right. It's a key
kind of
value
data I
pair.
can keep there?
Yeah, that's right.
Okay. Okay. So initially, when we were talking about why Cosmos DB, you talked about the integration with the AD of Cosmos
Mhm.
DB. And I remember it used to be just the key based authentication and authorization used to be there. And so what changed? Now you are saying completely with AD, I can define groups, people, and permission, and that will be obeyed by Cosmos DB.
Yes. So what happened is internally we did a lot of engineering to build in this support into our users and permissions model that we have internally. So we have our own permissions, users and permissions model that we've had since the very beginning. But we've expanded that and now enhanced that to support Azure AD as users, and then also RBAC policies across actions that happen within Cosmos DB. So being able to read data from a collection, or write data, or delete data. All the different types of RBAC actions you would expect for a database to do CRUD operations, whether it's read, write, update, delete, or query. All that stuff is all available via actions through role-based access control. And you can define custom groups on those and assign them to groups in AAD. So you can have a readers group, a writers group, whatever it is you want, or you can assign it directly to individual users within there, however you want to do it. But it gives you that flexibility to be able to go and define these sorts of layers, if you will, for authorization for reading and writing data as a Cosmos DB.
Perfect. Yeah, I'm very happy to see it released. I believe it's released last year.
Yeah, we first released this last year, um, in preview, and yeah, it's taken a while, and it's definitely something that customers that are obviously, if you're migrating to Azure, you need some way to do authentication and authorization for that. So this was one of those things. It was more of an enterprise promise for us to be able to support this. So we're very excited to be able. Other integrations as well, like our integration into synapse-link, also includes Mongo support, and this is another recent one, and where you can get kind of the integrations you cannot get anywhere else, right? So customers that have Mongo workloads and then want to go to build analytics on top of them can go and migrate to Cosmos DB, integrate or connect Synapse-Link with that, flow all of that data into the analytical store for Synapse-Link, and then go and create SQL serverless notebooks and write T-SQL over their data in Mongo and
Mm.
build analytics on top of that. I mean, that's just one
Okay.
possibility, or they could build Spark
Mm.
notebooks from that as well, and then get their data from Mongo integrated into the rest of our analytics and AI platform. Right, so there's a benefit that you could not get any other way. I mean, functionally free, you don't have to do anything. Just provision the account in Cosmos, provision your
Mm.
workspaces and notebooks and Synapse, and there you go. So
Okay.
um, the other differences as well is Cosmos is designed to be a multi-tenant service, right? Other NoSQL databases in Azure or elsewhere, well, there's some exception, but um, many of them are VM based, if you will, as a scale units within there. Cosmos, our scale units are very small. In fact, we call them, those are partitions, if you will. And Cosmos, as a horizontally scalable database, we don't, as your database gets bigger, you don't scale up like you do with, say, a relational database like a SQL DB or a Postgres or any other relational database that's out there. We're scale out. So you add additional pieces of compute or partitions um, when your data grows, or if you need additional throughput and power processing, right? So for us, that scale unit is an RU or request unit. And then to dial that up, you just add more request units. You're not provisioning VMs, you're not sizing VMs, you're not dealing with any of that stuff. You're just simply dialing it up. And then back behind the scenes, we will provision additional storage, additional compute necessary for you. And your workloads will scale up. And they do so
Mm.
seamlessly and automatically, by the way. You don't have
Okay.
to wait for that within there. The key there is you need to design such that your database will scale, right? And this is a trap we fall into, or this is a pattern we see with users that are new to this type of data store, is they're not familiar with techniques or how to shard or partition data. And even from a Mongo background, this is not something where we're still something we see where users prefer not to have
Mm.
to deal with issues of sharding, and will try to avoid it, and even other users as well. Um, it's a hard thing to know in some cases because it relies so heavily on the access
True.
patterns for your data. Um, for instance, you could have, say, an e-commerce workload, and I've got, say, a shopping cart in there. So I've got order information, and then I got a cart full of products, some payment information, shipping information, etc. Um, if I want to design a collection or a container to store that data, how am I going to partition that data? What am I going to use such that I can scale that out, such that I can work with either a couple of users or a million users simultaneously, right? So that becomes a very interesting question. Like, okay, which what access do I need to consider if I want to make sure that I'm fully utilizing throughput and storage as I'm adding users and concurrent users, right? Is really the key here. Um, do I use, say, an order ID on there, or do I use a state or some other thing, or maybe the customer themselves, right? So those things matter in some cases, and that's an easy kind of scenario to figure out what would you partition or shard that data by. But it's not always apparent, particularly if you're early in your design phase. And so one of the things we try to get people used to or comfortable with is the fact that you may have to iterate over your design as you go from, say, dev to test to prod, and even post production. I've seen customers go into production and be surprised by like kind of how the app was being used and didn't see maybe particular patterns and things. And so they came back and said, I've got to redesign this, and I need to copy my data. I need to migrate my data into a new collection with a new partition key because I'm
Right.
not
But I
designed to
believe
scale.
the beauty of Cosmos DB is if you have the right partition key defined, then everything is your hands off. You don't have to worry about anything. Even if your load is increasing, the users are coming, the volume of data has increased, nothing. It's all taken care of by the Cosmos DB behind the scene. And your responsibility is to have a good partition key. And that's where all responsibility of a dev ends and everything is taken care by Cosmos DB.
The design
Yes.
matters a lot, and you could write really terrible queries in, say, SQL Server and probably get away with it under significant load. With the database like Cosmos, your errors are laid
True.
bare, if you will, because it's not forgiving in that. At least from a scalability standpoint, it's not forgiving in that sense. And
Or even
um,
if the performance you don't feel it, you may feel it in the bill, in the invoices when it will come from Azure. Because if you have a bad query and it's scanning the whole partition and everything, you will very quickly know that what mistakes you are making.
that's right. And this is it's funny you bring that up because one of the things that users will typically do when they first stumble into performance issues after going into prod is they'll say, these queries are running slow. I'm going to increase throughput, and that should help make it faster.
Yeah.
Uh, what is odd is that sometimes increasing the throughput
Mm.
can make the problem worse, particularly if you're dealing with high concurrency for cross partition queries, because as you increase the throughput, you increase the number of partitions
To be scanned,
that
yes.
now have to be traversed or scanned over these queries. So it's a bit unintuitive, but adding throughput is not always the right solution. And in fact, in some cases I've seen it's actually makes things worse. Here's the key, though, and I don't want people to get scared about using it. The promise for a horizontally scalable database is the theoretically infinite scalability, right? As long as all you have to do is just keep adding additional slices of compute, then as long as you've got capacity and you're in wherever you are, you don't have to worry about running out of data. And one of the reasons why databases like these came to the fore is because companies back 10, 12, 15 years ago, and this is kind of where the internet started to take off, and you had folks like Facebook and Netflix and others who were building cloud scale types of applications, quickly realized that their MySQL databases or Postgres or SQL or whatever just could not scale, right? And typically there's a limit to the size of these things at about 4 terabytes, beyond which they don't work very well. But even as they approach them, the performance of a database like that, where you're going and swimming or trying to query through 4 terabytes of data or nearly 4 terabytes of data, can get pretty slow. Versus a database like this, I can be a megabyte in size or a petabyte in size. If I'm designed well, my latency, my performance is going to be the same, which is really quite remarkable, right? That I can have a single digit millisecond in latency for a request on a database that's a megabyte in size, or I've got a petabyte of data and I issue a fetch or a query or a read, and I can get that data back just as fast. That's remarkable in my opinion. And one of the kind of the killer reasons why you would use a database like this is, first of all, you're going to get really amazing performance. And I won't be shy. A lot of customers turn to us and use this for a cache because it's so fast. But also as your database, It's also something you want. I mean, a lot of applications are latency sensitive, but why take on additional latency where you don't need it? When you've got a database that can be super fast and do other things that I haven't even talked about yet. But we've got, as a fully managed service and as a NoSQL distributed database, we handle all the replication for you. So this is one of the killer features of Cosmos, if you will, is look, if you're going to run in a cloud, you need to design for failure, right? Because everything is running on commodity hardware. You need to have a business continuity disaster recovery plan in place, and that includes the planning of that, which means if a region goes down, if I lose connectivity to my application deployed in some region, what do I do about it? So 9 times out of 10, the guidance is you should deploy in multiple regions, right? One, it provides a way for you to gracefully fail over should your applications or database or whatever become unavailable. The other benefit it can provide is if you have users that are spread over a wide area, you can help increase the performance of the applications for those users, at least the perceived performance, because the data is going to be closer to them, right? And when it comes down to kind of performance, it's that requesting of the data that always seems to add the most latency when you were making a request from, say, a browser or a phone or an app or whatever like that. It's you got to hit the web server, the front end, or the API endpoint, whatever. But going and grabbing that data, processing whatever query it is, and then returning it is always going to add a lot of latency to your application. So if you can get that data closer, then it has less distance to cover, and the performance is going to appear to be faster because it didn't have to go all the way around the plant to go get your data. So that's another reason why. And the nice thing about Cosmos and why you would use it, say, that versus like some other NoSQL database that's not fully managed is we've already solved the problem with the replication. It's all built in. You just simply add the regions in there. The other thing we've done as well is we've made managing consistency for data between regions, and I should maybe explain consistency, but we've managed the consistency knobs, if you will, on that data when it replicates to other regions and made that very simple as well, or simpler, if you will. Now, the type of consistency I'm talking about is not ACID consistency, like you would find in like a relational database. It's really kind of the consistency for data that is replicated into different regions, right? And you can have different types. You can have a synchronous replication where any data that's written into your database has to be fully replicated and committed everywhere before you can ACK it back. That's good because you have zero data loss if you, say, lose a region. But there's a trade-off in that everything you write takes longer because it has to forcefully synchronize or synchronously.
Yeah, I believe you have about 5 consistency dials different between weak consistency to strong. You have multiple level of consistency, and you can choose depending on your application.
Yep. And that's, so compared to some of our competitors who offer maybe 2 or 1, there's additional flexibility there for how you want to manage that consistency. And it really, to put it more clearly, the consistency level you choose is really a dial on your RPO, right? Because what it really governs is what is the behavior for data that I write to be replicated into additional regions, right? And in the BCDR scenario, the reason you want to define that or have some control over it is I need to know what my RPO is should I have a regional failure, right? Now, if I use strong consistency, my RPO is 0 because I have 0 data loss. My data is written everywhere. I'm 100% consistent. Most of the time, customers will use a less stringent consistency model and will choose an asynchronous model like a bounded staleness or a session or a consistent prefix or even eventual on there. And what you've got is kind of a gentle slope between, very high latency, low availability to higher throughput and higher availability with these other replication or these other consistency models.
So, Mark, in between, you said, I just want to double check. You said that you can use Cosmos DB as a memcache, right, for the caching.
Well, we don't emit a memcache compliant interface, but you can use Cosmos as a cache just simply because it's so fast. Like we're the only database in Azure that gives a latency guarantee or a latency or an SLA on latency, which is for a kilobyte of data or less. You can read or write that data using our .NET or Java SDK using our direct mode. But any read write operation is going to be less than 10 millisecond at P99, right? So nearly 99.999 whatever the P99 for that. P50 for that is going to be even less. It's more like 4 or 5
So
milliseconds,
I
and sometimes
can
even
use
faster.
Cosmos DB as my
Uh,
cache store if I want. So
sure.
two more
Yep.
questions I have, Mark. One is, do you have a integration with Jupyter Notebook of Cosmos DB?
We do have notebooks. Great question. We've had that out for a while now. We had a bit of a security incident last September where we had some vulnerability identified with our notebooks offering. So we took it offline and then worked with our security team to make sure we took care of any of the issues, vulnerabilities that may have been in there, and then go beyond that, obviously. And we're now working to roll that back out slowly at first, but hopefully users over the next 3, 4, 5, 6 weeks should start to see that light up in the portal uh, for them, which is great because it also the notebooks are a really cool feature where you can. I mean, it's a nice in the way we did it. We provide kind of a GitHub gallery on these things, so users can go and create new notebooks and then share them with others and put them on the gallery so others can see them. But they do what notebooks are great at, which is being able to quickly and easily query data and then also visualize it as well, right? So you can have access to
True.
all those
And
little
and
cool
I believe
visualization
it is just
bits that
not
you
the
can do.
integration of like any other database where I can, put the connection string, write a code in Python and access the data. Here, I believe that your integration will make Jupyter Notebook partition aware of Cosmos DB. So if I'm querying the data, that Jupyter Notebook will hit multiple partition, and it is better than, I believe, other database integration with Jupyter, because it will be just a database and then you go and do things.
I don't know about the part. I'm not familiar with the partition integration, but I do know that um, it's it's very well done in terms of the integration in there. We have our own magics that we created that make connecting to and accessing the data within Cosmos very easy to do. So we really like that, and it's kind of a bummer that we've had to take it offline for a while, but we're looking to bringing that back. And it's a really great way to explore the service. It's a great way to explore your own data as well.
True. And last question. I know I can go to Cosmos DB and maybe I can get some free version for some time to play with and learn. Do you have still the local version where I can have it on my laptop and I'm flying, so I can still use without connectivity to?
We do. We have an emulator that we've built, and there's two flavors of that. There is kind of a downloadable, installable Windows emulator that you can just download the MSI and double click that and install that locally on your machine. And then you can just connect to that. The interface for that looks just like Data Explorer inside the Azure portal. So very simple and straightforward, and a very good way to go do development or dev test locally on your machine with or without an internet connection. We've also got a new Linux emulator that is available as a Docker container. So customers can go and acquire that and then run that as a Docker container locally on their machine. The caveat for that's a very new offering for us. Only supports SQL API today versus the others which support other APIs. It also, even though it's a Linux emulator, it only runs on Intel Silicon today. We are working on trying to make that work on non-Intel Silicon. So some Mac users have said, "Hey, what's up with that?" So we're the underlying architecture there is a bit tricky. We're working on that. It's definitely not trivial, making our emulator work on non-Intel silicon, but we definitely are going to do it. My suggestion is if you need something and you don't want to pay for it, but just want to do some dev tests, we have a free tier we've had out now for I think over a year now, and customers can get really good benefits from our free tier. We'll give you a 1,000 RU, which is pretty good. I mean, look, just as a comparison, like if you read a kilobyte of data using a point read, right? So you just read that data. Anything that's a kilobyte or less is 1 RU. So conceivably, you could go and write a little routine that reads 1,000 items a second, and you'd be within the free tier for this offering here. So there's an option: is use the free tier and then do your dev test on that. You get one free Cosmos DB account with 1,000 RU for every subscription within Azure. So if you've got a subscription, you got a free Cosmos account. If you have multiples, then go get multiples if you need them. But combined with that and then free tier, by the way, we've also got serverless, which has just exploded in terms of usage. Developers love it because they're not doing a whole lot of operations. They're just dev test right now. So it's pretty neat that you only pay for what you're used. And if you're not using it, you don't pay anything within there, right? Well, except for like storage. But when you're doing dev tests, literally there's no, I mean, it's like 25 cents a month for like a gig of storage. So that's not much to deal with from a billing perspective, but you're using the real service as well. Other restrictions is serverless doesn't provide SLAs on latency or availability. They provide SLOs because it's serverless.
So what do you mean by serverless? Today I want to use Cosmos DB. I'll go to the portal and instantiate one of the instance of Cosmos DB there, right, in my subscription.
Mm-hmm.
So when I go to the serverless, what I do, I still go to my portal and say, give me a Cosmos DB instance, but it may not be the instance for me. It may be a shared instance. What does it?
Well, I mean, it's Cosmos is a multi-tenant service, so there is that as a service, right? I mean, we
Right.
keep customers and data isolated.
How serverless is different from the original offering of
Yep.
Cosmos DB?
So the way it works is with regular provision throughput or even autoscale, you have to set some amount of throughput or RU per second in there. With serverless, you do none of that because you are billed by the request, right?
Okay.
So you get request, like you pay some amount over 1 million requests, and then that's it. So that's the serverless portion. Cosmos is already serverless, I guess you can say in that.
Yeah, that's what I was.
You don't have to deal with VMs or anything like that.
Yes, exactly. That's what I was wondering about.
It's serverless plus because now you don't even deal with throughput on that. You just create the account and then say it's serverless, and then everything underneath in there is serverless.
Cool. Very good. So, Mark, thank you very much for your time. It's really good fun. Learned a lot of things from you. So
Good to see you, Rafat. It's been a while, so
yeah,
good to see you again.